Barry Bonds. And then boom, right, 73. The one below it is the home run totals year by year by Hank Aaron. Okay, so those are the numbers we're working with as you're going through your book and you're looking at these. It's the same numbers that we worked on in class. All right, we're going to beef some stuff up today, big time. We're going to beef up spread in a big way. Your write-up for spread, which up till this point, maybe you just talked about the high and the low, you talked about gaps and clusters, maybe you talked about range. Now you're really going to be talking a lot more. Okay, there's a lot more that you're going to talk about in spread. And then finally, up until now, we've been saying, well, that number looks really far out there. It might be an outlier. Now we actually have a mathematical formula which you're going to use to calculate whether you have an outlier or not. Now, I didn't tell you this last night, but starting tonight, you need to understand that. Anytime you use a formula, something off those green sheets, actually this one's not on the green sheets, you have to memorize this, but anytime you use a formula in this class, this is how it works. You write the formula, then you plug in the numbers to the formula, and then you do the calculations. Okay, it's critical on the AP test in May that you do it that way. Here's why. If you've got the right formula, and you plug them in right, and you just make some mathematical error, they're going to give you full credit. But if you just show them an answer and it's wrong, you're not going to get any credit at all. So you've got to show them how you were getting the problem done as well as getting it done. So from now on, anytime you're using a formula, make sure you write it down and plug them in as we go. All right, spread, also known as variability. Sometimes you'll hear people say, what's the variability of the data? They're talking about spread, how spread out the data is. Okay, so just be aware of that. If it has high variability, if I give a test and I've got high variability, I'm not happy. I mean, I got some students that maybe did really good, but I got some students that did really bad. There's a big spread in the data. If I give a test and it has low variability, okay, that means everybody kind of got around the same grade. That could be kind of a good thing when we're talking about test grades. So just understand, you see the word variability, it says the same thing as spread. All right, this is the one we've already done before. They finally defined what range is. Remember, the range is the high value minus the low value. So over here with Bonds, 73 minus 16, about 57. So his range is about 57. Whereas Hank Aaron, 47 to 13, it's about 34, much lower. So I can say that Hank Aaron, just based on range, has far lower variability versus Bonds, which has much higher variability. Okay, when we're talking about the range, if we're comparing the two of them. But now we're going to define in a lot more detail what's going on. The word quartiles. All right, the symbol Q1 is going to say, we're going to stand for the first quartile, and what it is the 25th percentile, which you now know, whatever the home run total is, 25% of the years, he got lower than that. That's the 25th percentile, and that's going to be referred to as Q1. Q3 is going to be the 75th percentile. So whatever that home run total is, we know that 75% of the years he had home run totals that were lower than that. Okay? So how do you find those quartiles? So if we go back to our data over here, here's how you do it. You line them up in the middle. Now, you take the first half of the numbers and you just find the median of that. So in this particular case, we had 8 numbers over here, 8 numbers over here. We go find the median of the first 8. 8 plus 1, 9, 4.5. So I count 1, 2, 3, 4.5. So Q1 is 25 homers. Doing it on the other side, do the same thing. Just find the median of these. 1, 2, 3, 4. So Q3 is 41 homers. Now things are a little bit weird. Now some calculators do it one way, some books do it another way. This is how our book and calculator does it. What do we do with this 38? Because it landed right on a 38. Our book and calculator just eliminate that number. Now go find the median of this side, go find the median of that side. It's not going to be a big deal whether you leave it in or not, but that's just how our calculator does it. So what do we got over there? 10. So we go to 5.5, 1, 2, 3, 4, 5.5. So Q1 for Hank Aaron is 28. Do the same thing on the other side. 1, 2, 3, 4, 5. Q3, or the 75th percentile, is 44. Yes?
So when we're finding the quartiles, if The median is just one number we act like it's not there.
Yes.
Okay.
That's how our calculator does it. Now, this inner quartile range, I'll find that in a second, it's from here to here, half of the data is between here and here. Right? 25% of the data there, 75. So half of the data, half of the years are between 25 and 41. Half of the years for Aaron, half of his years are 28 to 44. If I told you Aaron got, I don't know, 30 homers in a year, you'd say, well, that's inside of his middle 50, the meat of his years. There's nothing unusual about that. You know, if you're in the lower teen percentiles or up above 75, you might say that's a little bit unusual. Okay, so that middle 50% is really a big deal. It shows the consistency that they have. Now, we'll define another calculation for you, and it's called the IQR, or Interquartile range. We know that just the range is the high minus the low. But the interquartile range finds the range just between the 75th and 25th percentile. Hey, you know, in general, that middle 50%, how consistent, how variable was in those middle 50%? So let's go calculate the IQR for bonds. Now, I got a formula. So we write it down. IQR is Q3 minus Q1. We plug in the numbers. 41 minus 25. So the IQR, or interquartile range for Barry Bonds, was 16 homers. Go find the interquartile range for Aaron. Go calculate the interquartile range for Aaron. So we write the formula, we plug in the numbers, and we do it. For Aaron, we've got 44 minus 28, we got 16 again. So where we can say that the overall range is much more variable for bonds, when we look at the meat of their years, their middle 50%, they had the same kind of consistency, the same variability. Okay, these are the words you're now talking about in here. You just don't write down what the quartiles are, 6, 41, 20. No, you talk about the IQR, and you would compare them to each other. Okay. All right, we actually have a graphical representation of the IQR and the different quartiles, and it's called a box plot. In a box plot, we are going to take a graph of what we call the 5-number summary. The 5-number summary consists of the minimum score, the 25th percentile, the 50th percentile, the 75th percentile, and the maximum score. If you want to take a look at what one looks like, you can look on page 45. Look at page 45. All right, I hate that one. That one's going up and down. I hate the ones that go up and down, although you might see one in the future. I like the ones that go horizontally. If you turn the page, you'll kind of get a glimpse of what ours are going to look like. Okay, so when we draw box plots, that's what they're going to look like. All right, 4 key steps here, and if you skip one, I can promise you your box plot's not going to look right. The first thing that we have to do is draw our number line. Okay, so I'm looking at these, I see a 13, I see a 73, so I'm going to draw a number line that, I don't know, starts at 10 and goes all the way to 75. Starts at 10. I'll go by 5s, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75. And you can fill in the numbers here. That has to be your first step. Do not do that. Almost promise you your box plot's not going to look right. This box plot is going to help us determine a lot of things. One of them is spread, so that's why we have to make sure we have that number line first. All right, the next thing we do, and some of your old books, old-time books used to call this a Box-and-Whisker Plot. I don't know if any of you have ever heard that, probably not, but that's what we're drawing here. All right, now we draw a box around that middle 50% of the scores. We're going to draw a box around Q1 and Q3. So we'll do bonds. So we've got 25 to 41. So you go to your number line, and we're going to draw a box from 25 to 41. Draw a better box than that. Half of Bonds' home run totals are in that range. That's our interquartile range. I think what Bonds has 16 years up there, 8 of them are in that range. So that's what I want you to start kind of keep in mind when you're drawing these shapes. Then draw a line through the median. The median for Bonds was at 34.
Yeah.
So go find 34. It's interesting. It's almost right in the middle of the box. And then we're going to draw, it used to be called whiskers. Now we're just going to draw lines out to the minimum and the maximum home run total. So the minimum was 16. The maximum's all the way here at 70. So I told you that the box plots are great for determining shape. With Madison, do you think you can get... they're great for determining spread, but do you think you can get shape just by looking at that box plot? Shape. Now, can you also get shape by looking at the box plot? Remember how we do? We look at a picture.
Oh yeah, because you see how it's gonna like skew to the right.
Yes, that 73 was way out there, right? This has the longer tail, if you will. We got another tail here. It's not a, it's not a picture, but it's from, if looking from the median, doesn't the 73 go way further away? So what's the mean going to do? It's going to be attracted to it, right? Yeah, you can see that that's in fact skewed right. All right, right above it, I want you to draw the box plot for Aaron. Go. Okay, there's some very unique features here. Check closely your box plot. Box plot doesn't look anything like my box plots. I'm looking inside the box specifically. You see that? I had a great question third period. And they said, well, wait a minute. How come that's not right in the middle of the box? I don't understand. Okay, first of all, you're going to draw a box plot just like this if you don't do the number line. Every single box plot looks like this. Perfectly symmetrical. But that's not what box plots really are. We want to see the difference in these various quartiles. Now let's think about what this means. Okay, this is between the 50th percentile and the 75th percentile. For Aaron, those years, what creates a small little quartile like that, during those years, he got basically kind of the same score over and over again. Let's take a look at Aaron over here. In this third quartile, it didn't go very far. Okay, that means something. Somebody, third period, said, I'll bet that's where there's a cluster. Right? If I have a whole bunch of scores that are around the same thing, it creates a cluster. Well, in a box plot, I'm going to have, what do we have, 4 or 5 scores in there that aren't that far apart. They have low variability. They're bunched together. And look at old Bonds down here. In the fourth quartile, in this area, it's the same number of years I've got in each one of these, but they're much more spread out. I bet there might be a gap in there. So your job now in spread, it's not to write down what these quartile numbers are, it's to evaluate the similarities and differences. If I was doing a write-up in spread and I was comparing Bonds and Aaron, well, I'd talk about the range, of course. Bonds was much more variable overall. The IQR both being 16, the middle 50% of the data was the same. But now go in even further than the middle 50% and go into the various quartiles. Okay, you want to think of this as the first quarter, second quarter, third quarter, and fourth quarter. The third quartiles between the two players was much different. Bonds was much more spread out than Aaron was. And the same thing in the fourth quartile. Again, Aaron had a lot of consistency out here. Look at this. All of his scores were about the same. That's going to create the small number. But look at Bonds. That's what creates the long line. So you would definitely be talking about this. You would be discussing that in your write-up of spread. You go to the individual quartiles to talk about the similarities and differences in spreads. And a box plot's what helps us do that. Questions, comments? Yeah.
Are you ever not going to have a line at the end of it? Like, what if all the Hank
Yeah,
Aaron
yeah,
test numbers?
yeah.
40?
Yeah, you do one, I think, for homework. Well, the question is, what if these were all 40s? All the way to the end? Well, not only would it be small, you wouldn't have a line at all. Okay? But that's how you have to look at these box plots. You have to understand the differences between a long line and a short line. All right, it's through this 5-number summary, and actually this is the quartiles, that we actually now have a formal definition for an outlier. Up until now, it's been, boy, that thing looks really far away. Now we've got a mathematical test to see if we have an outlier or not. And just in general terms, I mean, I'm wondering about this 73, right? It looks like it could definitely be an outlier. Here's how they do it with this formula. We're going to start at Q3, so that's right here, and we're going to add 1.5 of these. So that, a half bigger, we're going to add it to here. And if you've got a score outside of that, we're going to consider you an outlier. That's kind of in general what an outlier formula is. All right, let's get specific with it now. And this is what you're going to be doing when you write outliers now. Now you're going to be doing a mathematical test to see if you have an outlier or not. So let's go ahead and do Bonds' high side right now. So let's see if Bonds, let's see if that 73 was an outlier. So what we're going to do is we're going to use this formula to see where the boundary is. All right, so for Bonds, Q3 was 41. So first we write the formula, of course. Q3 plus 1.5 IQR. Now actually, if you want to be more specific, the IQR is Q3 minus Q1, isn't it? All right, so Q3 was 41 plus 1.5, and then it's 41 minus 25. It's 41 plus 1.5 sixteens. 41 plus 24. So we get the number 65. An outlier is defined as any number outside of 65. So in this particular case, was Bonds' year crazy compared to what he normally did? Yeah. I wonder what happened there. Okay. All right, go see if the low one was an outlier. So do the outlier formula on the low side and see if 16 was in fact an outlier. Yeah.
Yeah, so is the protocol just to always figure out what the outlier limit would be?
Yes.
And then see? Okay.
Yes. Check it out. So when you do center, shape, spread, and outliers, you've got some mathematical work to do on outliers now. It's not okay to just say, I think. Yeah.
Are we going to want to show that work in the outliers?
Yes, that's where you're going to show it. Okay, you're going to write down a formula, you're going to plug in the numbers, you're going to get your boundaries, and you're going to say whether you have an outlier or not. So I'm kind of doing the outlier work, right? Then you write a sentence telling me what you've got. All right, notice with the low one, you start at Q1, right? You start at 25th percentile. Okay, notice that difference there. That's kind of a big deal. Minus 1.5 IQRs again. So Q1 for Bonds was 25. Minus 1.5 sixteens. 25 minus 24 equals 1. So that's the boundary. So did he have any home run totals less than 1? No. So we just have the one outlier. It would be nice on these box plots if we could show outliers. It's kind of an important measurement. And there is a type of box plot that does that. It's called a modified box plot. And everything's the same. You still set it up the same. However, if you've identified an outlier, we're going to identify that year, that home run total, with a dot. So we had an outlier over here. So what's going to happen here is Bonds is going to get a dot out here at 73. Now, this is the part that's tricky about this. Yeah?
well, you might show it, but so you erase the line completely.
Yeah, this is the part that's tricky here. We then have to draw the line to the next largest one closest to 73 that's not an outlier. So going back to the original data, I mean, if we'd have had another 75, we'd have 2 dots out there, right? But the next one that's not an outlier is 49, so that's where we draw our line to. This is definitely a tricky multiple choice question that's in your future. Yeah. Okay? So this is called a modified box plot. Now just remember, this Q4 is still longer than this. It just shows you if you have any outliers. All right. Fortunately, our calculator does this stuff for us. Okay, so we'll be able to draw them quickly on our calculator. The hard part is all the write-ups that you have to do to interpret what you've got. Well, let's go ahead and draw some box plots. All right, here we go. Go into your stat plots now. I turned them all off. So I'm going to turn the first one on, and you go down, and you have to find, here's our 2 box plots. There's the original box plot, and there's our modified one. So let's just go to the original box plots first. Now, I had a lot of questions on this. You've got to be careful. You hit the side toggle button to get to that one. So you go side, side, and it goes down to the lower one. So I'm going to go down to the regular box plot and enter. My data was in L3. That's where my, I don't know where Bond's data is, I think. So now if you go to Window, what did we do down here? We went from 10 to 75. Now, if you don't care, you want to let the calculator do that, you can go to Zoom Stat. But if you want to set it up to look just like ours, I'll go from 10 to 75. So I'm going to start at 10 and then go to 75 by 5s. And now if I just hit Graph, there it is. Blammo. The window part, I just set this up here. Remember we made a decision to start at 10 and go to 75, setting up my number. Yeah?
And it doesn't really affect how high.
No, that doesn't mean anything. You're doing that here. I think if we make this smaller, it'll come down or something. But we can actually put both the box plots on here. Go back into your stat plot and turn on your second plot. And I'll do a regular box plot. Now you got to change where that data is. Mine were in L3, L4, so you got to make sure you have the different spots. And now if I hit Graph, because I've already set up my window, there they are. Those are the 2 box plots that we set up. All right, go in and do modified box plots and see if you get the modified box plot. So go back into each one of them. Go down to the one with the dots. Change them both. And you'll actually find that Aaron didn't have any outliers. We could do that math to show that, but you're going to see Aaron's doesn't change. His high and low stay the same. Didn't quite have the steroids back then. All right, so I'm going in here, going down, right there. It's asking you what do you want the kind of symbol do you want on that. I'm going to go into Boxplot 2, go down and do the modified. Now I just hit Graph, and there's our pictures. Okay, so I mean you have to know how to do this by hand, but eventually where you're going to get to, you're just going to have a bunch of data, you're going to draw a box plot, you're going to put it up on your thing, and then you're going to write about it like crazy. Spread just got huge, people. Okay, if you're comparing and contrasting, are you looking at the 2 ranges? Sure. You're looking at 2 IQRs, you bet. You're even going into the individual quartiles and talking about the difference in variability. All right, any questions, comments?